Chapter 9, Section 9 in the 8th grade note-taking guide is entitled Scatter Plots. This is really one of our last graph types to take a look at. Scatter plot, as we've talked about, is kind of transitioning us back into those graphs that display actual pieces of data. But here you're really going to be graphing data pairs as opposed to one data set inside of a category. When we're looking at scatter plots, we're looking at data pairs. So whatever two things you want to try and compare to see if there's some type of relationship, which is really what a scatter plot does very well, is what you can graph. So if we were, for instance, looking at your score on the English part of the I-STEP and your score on the math part of the I-STEP, we could make a scatter plot of that. If we were looking at somebody's age and somebody's weight, we could make a scatter plot of that. Example 1 is a really good example of a scatter plot where we're looking at somebody's height compared to their weight to see if there's a relationship. But what's important here is you're graphing two pieces of data together. As you can see looking down at example 1, scatter plot looks a lot like a line graph, but you're not connecting the dots. And we've made these before, so that's nothing new here. All right, so what is a scatter plot properly? It's a graph with points plotted to show a relationship between two sets of data. A graph with points plotted to show a relationship between two sets of data. Now, depending on how the dots line up on the graph, you can have a correlation. Correlation is the description of the relationship between the data sets. As we learned last year, there's three different types of correlation that can exist. There's a positive correlation, a negative correlation, and no correlation. And then we've also got the line of best fit. The line of best fit is a straight line that comes closest to the points on a scatter plot. Again, quickly, a scatter plot is a graph with points plotted to show a relationship between two sets of data. A correlation is the description of the relationship between data sets. And the line of best fit is a straight line that comes closest to the points on a scatter plot. All right, so let's go ahead and scroll down and take a look here at number 1. In number 1, it's asking me to use the given data to make a scatter plot of the weight and height of each member of a basketball team, and then we're supposed to describe the correlation. So as you can see, they've kind of got the graph already set up for us with the heights on the x-axis, since that was the first piece of data they gave us, and weights on the y-axis. They've done a line break on both these lines here to indicate that they've skipped some numbers. We talked a little bit about that yesterday in the instruction. But what you can see here is on the heights, since my smallest number is 68, they start the graph at 68, and they're going up by ones. On the y-axis for weights, smallest number here is 160, but they start the graph at 140 just to have some gap there, and then they go up by tens. Again, same consistent amounts here. You've got a label on each axis, which is good. What this graph doesn't have is a title, and it should. So we'll go ahead and put a title on here. I'll call this basketball players because it's about the heights and weights of basketball players. All right, so once we get our graph set up, we're ready to go ahead and graph. So we're going to put a dot at 71, 170. So right to 71 up to 170, put a dot. 68, 160. Right to 68 up to 160, put a dot. 70, 175. Right to 70 up to 175, put a dot. 73, 180. Right to 73 up to 180, put a dot. And 74, 190. Right to 74 up to 190, put a dot. And that's where the dots on my scatter plot come from. Okay, so we took care of the graphing. Easy, a lot like graphing in the coordinate plane. We're used to that. We've done that. Nothing new. All right, now we have to, as the question says here, describe the correlation and tell what's going on here in this graph, which is also not really a big deal. So what we see here, as these numbers look to be getting bigger, the heights here are getting bigger. The weights are also getting bigger here. Well, when both numbers are getting larger or when both numbers are getting smaller, that would describe a positive correlation, meaning the two sets of data are moving in the same direction. Either both are going up or both are going down. If they could be going in opposite directions, one piece of data was to be going up and another piece of data would be going down, that would be a negative correlation. And you could also have a no correlation where the data just stays flat some way or another. Now, let me put this a different way here. If I were to take my ruler and to try and draw a line around as many of those points as I can, the line that I would draw here in number 1 would probably look like this. When you draw a line of best fit, which is something we define, we try and draw a line through as many points as we can and also leave as many points on either side of the line in equal quantity. So here, by drawing the line like that, I've got about the same number of points above and beneath the line there, and it represents that data set fairly well in that it splits through the data set and how would we draw the line to fit those data set. All right, that is a positive correlation anytime the line points up. If the line were to go down from left to right, then it's a negative correlation. If the line were to point straight up and down or straight left to right, or you just couldn't even draw a line, that would be a no correlation type of question. All right, let's go ahead and take a look here at number 2. Number 2 asks us to make a scatter plot of the data and draw the line of best fit. Then we're supposed to use the data to predict how much a worker will earn in tips in 10 hours. So as you can see here looking, we've already got a scatter plot drawn. Actually looks more like a line graph because so many of the dots happen to be right on the line, but you can see here we do have a couple that look like they're just a little bit above or just a little bit beneath, so it's not exactly a line graph. This is a scatter plot. So we've made our scatter plot here. The tips earned may be dependent on the number of hours worked. As you can see, they've let the hours worked be the independent variable x. Down here, the hours are on the x-axis, that's why they're saying x. And the tips earned represent the dependent variable y. And as you can see, the tips amount here is on the y-axis, that's why they're saying it's y. All right, so what they want you to do here is draw that line of best fit that we just drew in the last one. Again, they're drawing the line to go through as many points as they can, and for whatever points they can't get through, have about as many points above the line as they do beneath the line in equal spacing and in equal quantity. So they drew that line there, has about the same number of points above and below it, and they ignore the outliers when they draw a line of best fit. Now the outliers here really aren't that obvious, but if, let's say there was a dot way up there. All right, if there was a dot way up there, we wouldn't do anything like that for the line of best fit. I'm not going to take and skew my line this way for that one piece of data that's off. You stick with the bulk of your data, which is what they're saying in step 2. All right, so the question here is, how much money will that worker earn if they work for 10 hours? Well, once we draw the line, all we have to do is go up from the 10-hour mark to see where the line is. Well, as I go up from the 10-hour mark here, I see that when I read to the left, that the tip amount looks to be about 24. And that's going to be the answer to the question here. If I work 10 hours, I'm probably going to make about $24 in tips. All right, let's go ahead and take a look at the concluding example here. Number 1, use the given data to make a scatter plot of the weight and height of each member of a soccer team and describe the correlation. So as you can see, you've got your plot there of the different heights and weights of members on the soccer team. Looking at the graph that's already solved out for you there, one of the things you should see missing right away here is a title. So we're going to go ahead and put a title on this graph. Notice our graph has labels on the axes. Neatness is accounted for. You don't need a legend or a key because you're only comparing one possibly related set of data here, a set of data pairs. So, graph here looking at the x-axis is going up by 1, starting at 60s. Notice they used the line break to skip everything from 0 to 59. Same thing on the y-axis. They skipped everything from 0 to 100, started at 110, and then went up by 10s. As we talked about yesterday many times, how you number this is really up to you. If you wanted to go up by 5s here or maybe 20s here, that would be fine. If you wanted to skip every other number here, that would work too. There's lots of options here on how to make a graph that would still be considered accurate. All right, so let's start with the first data set here, 63, 125. So I'm going to go right to 63, up to 125, halfway between 120 and 130, put a dot. 67, 156. right to 67, and all the way up to 156. So just halfway between 150, past 150, halfway between 150 and 160 is 156. 69, 175, all the way right to 69. Halfway between 170 and 180 is 175. 68, 135, right to 68, up to 135. Halfway between 130 and 140 is 135. And 62, 120, right to 62, up to 120, put a dot, and there you go. All right, so now they want to know what type of correlation there is here. Well, if I was going to connect the dots, I would probably put my ruler down about like, maybe like that or so. Not perfect, perhaps, but close enough. But what we do see going up from left to right, the line is going up from left to right. Whenever the line goes up from left to right, that's a positive correlation. So what we're demonstrating here is indeed a positive correlation.